Deep learning and machine learning. So we are taking the interview question and answer. So this is useful for interview, quiz, examination. So we are talking about artificial intelligence. These are basic interview questions. What is the difference between machine learning and deep learning? So in both of them, you see, learning is already there. So they come under the umbrella set or the bigger set, which is the artificial intelligence, AI. And inside this, we have machine learning. So this is supervised, unsupervised, and also the reinforcement learning. Inside this, we have deep learning. This is a subset of machine learning, and this is based on artificial neural network. So whenever we talk about deep learning, we are trying to mimic the human brain in terms of structure called neurons, and therefore forming the artificial neural network. So in machine learning, we use statistics and algorithms to train machine and data, thereby helping them improve with the experience. So deep learning, whenever deep learning comes, you have to think about the neural networks, your brain. So you are trying to make a machine like yourself, like intelligent people. So first artificial intelligence, then machine learning, then deep learning. What is perceptron? Perceptron. So perceptron is a single neuron with a single output. So perceptron was given by a famous scientist first. He actually showed that how a neuron can be shown, projected and computed. So what is going on here is a neuron, single neuron is getting some input, and these inputs, the lines which you see, if you see the inputs are say x1, the weight is w1. Weights are simply the importance given to that x1 or x2. So we multiply this x1 and w1, x2 and w2 till the xn wn. And then you send it to the neuron. Then you add a bias. Bias is simply a value, just we don't want it to go always from the origin. So we add them, and then finally we pass it through the activation function. So this perceptron is mainly used to perform binary classification, where it sees an input, computes functions based on the weights of the input, and outputs the required transformation. So this is actually neuron in human brain. How is deep learning better than machine learning? So machine learning, the deep learning is the subset of machine learning, which in turn is the subset of artificial intelligence. Machine learning can be of three types: supervised, unsupervised and reinforcement learning. Inside this we have deep learning. So here we are talking about it is having an upper hand on the machine learning, because we are talking about large number of dimensions. So we want to have a machine which is based on general AI or say strong AI. We haven't achieved it, but we want it. So with data which is of large size, deep learning can easily work with it, as it is built to handle this humongous amount of data. Huge data, big data, all kinds of multi-dimensional data. So wherever we talk about forward propagation, backward propagation, we want the machine to learn how to recognize, how to distinguish. So if you see here also the pattern, how this neural network and the traditional machine learning algorithm, on the basis of accuracy and data, they vary. So with more data, the things changes. That is why there is an advent of and the thrust on the deep learning, because of the humongous data which is there on the platforms, maybe social, otherwise. What are some of the most used applications of deep learning? Most used. So whenever deep learning comes, you have to just think about the neural networks. So there are a variety of fields today. So we have the applications of machine learning also, just for your understanding, and the applications for deep learning also. So in order, if this question comes for machine learning, you can give that this image what is shown. But for deep learning, sentiment analysis, computer vision, automatic text generation, the object detection, to detect very precisely natural language processing NLP. If in Gmail, if you write as soon as, or even if you write as soon as possible, will come automatically. That is natural language processing. Image recognition also. What is the meaning of overfitting? When you try to overfit the data, that is called overfitting. Okay. Now let us understand with the diagrams. Overfitting. Along with this, we have underfitting also. So overfitting is a very common issue when we are working with deep learning. So what is the scenario here? The deep learning algorithm vigorously hunts through the data to obtain some valid information. It just goes and tries to find out some valid information. So this makes the deep learning model pick up noise. For example, you have thought you will get 80 in exam. You predicted it and you got 90. So you overfitted and you got 70, that is underfitted. So now deep learning model is, because of it is vigorously hunting, it is picking up the noise rather than the useful data. Okay? Causing very high variance, because if you are taking noise and the actual data, there will be high variance between these two and the bias will be less. So actual data, noise, and it starts picking up the noise because it's working with that intent to work hard to get the actual result. So the accuracy which wanted we don't get. So the model becomes inaccurate and there are undesirable effect which is seen. So if you see, this is the underfitting. Too simple to explain the variance here. And here you see overfitting. It's being overfitted here. Force fitting, too good to be true. You cannot have like this, or even if you have this, then the noise will be more than or it is being picked up more. What are activation functions? So in one line, this activates the neuron. In one line, activate functions activate neurons. So activation functions, these are different kind of functions I wanted to show you. These are entities in deep learning that are used to translate the input into usable output parameter. That is, this function decides neuron will get deactivated or activated. Okay. So what is done here is, let me just give you a brief here. I have to take you to the background also. This is your neuron. Now you have given some input. Say this neuron is in your input layer. So you have given some weights also. Weights are just the importance given to the different inputs. Now when you pass it, x1 into w1, x2 into w2, these are multiplied and added, and a bias is added. Now these values for multiple neurons, this is not one neuron, there will be multiple neurons. x1 w1 plus x2 w2 plus xn wn plus a bias for a single neuron, there will be some value. And this value, the bias is just, we don't want things to go very precise, or you can say very unrealistic. We just want this C to be added so that we don't want every time the origin to be taken. Realistically, we add bias. So, but this is not one neuron. There are multiple neurons here. For example, you get some value, 2 lakh. This may be ambiguous, 2 lakh or -2 at 2 lakh, maybe. You don't know. So we use activation function. Whatever value is coming, we will always fit them into, say, a range, -1 to 1, 0 to 1. Now all the values which the different neurons are producing, we need a proper boundary. For example, the sigmoid function gives you the value always, whatever you put it inside, it will always give you from 0 to 1. So all the values which are coming outside will be easily to handle. Why is Fourier transform used in deep learning? So this Fourier transform is all about converting, changing from time domain or spatial domain to the frequency domain. You get frequencies here. The different kind of Fourier transform. You have the fast Fourier transform like this. So this Fourier transform is an effective package used for analyzing and managing large amounts of data present in our database. Large amounts of data. It can take in real-time array data and process it quite quickly. So this ensures that high efficiency is maintained and also make the model more open to the processing of various different variety of signals. So as I'm telling, if you apply FFT, fast Fourier transform, it will be more faster. So it gives you efficiency and it is able to handle or manage large amounts of data as well present in the database. Fourier transform, that is why it is used in deep learning. What are the steps involved in training a perceptron in deep learning? Perceptron is the basic part of any neural network because perceptron is all about one neuron with multiple inputs and single output. So if you take any neuron, there will be a series of steps. I have highlighted these steps. You can go through, but let me show you how actually things are done. Here we want a cat or dog to be recognized. So how to train a neuron, that is a perceptron. So say if you have given some input cannot be changed. It will always be there. So we have weights for each input, how much importance you are giving to certain inputs. You have weights for every input. You add bias when you multiply x with w, x1 w1 plus x2 w2 plus xn w1 plus the bias, and then pass it through activation function and some value will come. So now when you get the actual value, which may be different from the predicted value, the true value and predicted value may have difference, then you send that value back that okay, you need to change the weights. This is done again and again. This is how you train a perceptron. What is the use of loss function? Loss function. So what is loss here? People generally confuse this with the mean squared error. So let me show you what exactly loss is. So you can just read the text. I'm going to tell you the whole process. So in every neuron this is going to be done. So you have an output. Say the output is coming as 5. You wanted 3. 3 is the actual, 5 is the predicted. So what is the difference? 2. Now this you have to do for every neuron. For example, some neuron is giving you say 2.5. So what is the difference? You wanted 5, 2.5 has come. So 2.5 is the difference. So basically there is an error of 2 and 2.5. How to combine them? We just take the true value and the predicted value, we subtract them and we square them because we don't want the negative values. And after that you can square root also. Square and then take the square. That is mean square or mean square root error. And you have to divide it by n also because there are number of samples, number of data which you have inputted. Okay. So this shows that what is the error in your prediction of the neural network. But now you need to how to get this mean square error as 0. What you will do? x1, x2 you cannot change. You can only change the weights or the biases. So now you have to change the weights. So you have to write a loss function. That is, you have weights, x, input value you cannot change. That is already there. Weights you have by yourself chosen. The biases you have chosen. So W1 to Wn and B1 to Bn. These will all are the variables that you have to deal with in a loss function. So this is called a loss function. Then if you want to, because we use the partial derivative, because one time you are dealing with W1, one time you are dealing with W2. So you want one to keep constant, one to derivative and others to keep constant. That is why you take derivative. And finally a value comes after applying the chain rule, and that value is the actual value you need to change or given to weight that okay, you need to be changed by this number, and then the final until your MSE becomes 0. What are some of the deep learning frameworks or tools that you have used? This is a very common question in interview. Always asked, because by this the interviewer will know that whether you have worked on this or not. So you need to know which is coming from Google, what is coming from Amazon, from Facebook, from Microsoft. For example, PyTorch is coming from Facebook, the Tensorflow is from Google, the CNTK from Microsoft, MXNet from Amazon. So Tensorflow, Keras, PyTorch, Caffe2, CNTK, MXNet, Piano. These are all the deep learning framework which are available, being used by different, like for example, Keras is just a wrapper. Tensorflow is a low level kind of say library. Similarly with PyTorch. What is the use of swish function? Swish. Why we are talking about swish function? Because it has come from Google, and we know whatever Google has done, it's always successful. You talk about Google Pay, you could talk about YouTube, anything Google has presented, always successful. So previously people were using sigmoid, then they started using ReLU. Then this orange line is actually depicting the sys function. So it is now a very popular activation function, and this ReLU function will be 0 till origin from left, and it goes like this, a straight line, alright. And this is the sigmoid kind of curve, S curve. But when we talk about this swish, Google is claiming that it is outperforming all the other activation function in terms of computational efficiency. What are autoencoders? Autoencoders. Actually, it's not only encoder, it is combination of encoder and decoder. So there are multiple purposes of this autoencoder in artificial neural network. Or these are basically ANNs which learn in unsupervised manner. So autoencoders, artificial neural network, unsupervised learning. These networks have the ability to automatically learn by mapping the input to the corresponding output. That is, the image if you give, it should come the same way. Then input should be equal to output. So it has a taper till it goes to a certain computation state which we want. Then again it elongates till we get the final same number of neurons as the previous one. So for outlier detection it is very good, autoencoders. For the compression it is very good, and for reduction of dimensionality it is there. So this shape, like as I said, this is the shape which you must remember of autoencoders. The first part is encoder, second is decoder. So encoder, this is used to fit the input into an internal computation state. Here, decoder is used to convert the computational state back into the output. This is the autoencoders. This question will definitely come. What are the steps to be followed to use the gradient descent algorithm? Now, first thing is the gradient descent algorithm is for optimization. Let me tell you again, we have discussed it, but we have to discuss it again. We have x1, we have xn, different inputs. So let us just assume x1 is there, it is having weight. The output will come, mean square error you will find, you will see the difference, what is the difference, and then you will try to make a loss function. Then you will take, because I'm just assuming x1 with weight 1, there are multiple xn. So we'll take the partial derivative, we just want to change the weight 1, then we wanted to change the weight 2, so we'll take the partial derivative, and this is to be done with all the weights and all the biases. So just assume that we are doing it for weight 1, and when we do this, we get a value, and that value has to be deducted from the weight, actual weight, and that deduction will always be done so until the proper weight for the actual output, good output, is achieved. So this W1 is W1 minus eta delta L by delta W. For example, 0.55 is coming, we want to get a boy or a girl. Boy is 1, girl is 0, but the neural network is giving 0.5. So delta L by delta W1 is 0.24. So you have to subtract this 0.24 into some eta with the weight, because you're not getting the good result. So this W implies W, or W is equal to W1 is equal to W1 minus eta delta L by delta W1 is your gradient descent. Here eta is the learning rate, it is between 0.0 to 0.1. So you are actually changing the weight because you want optimization. And there is a concept of local minima and local maxima. You don't want a local minima. This gradient descent is only about finding the slope and taking you to the exact point where it should. Differentiate between a single layer perceptron and a multi-layer perceptron. In single word or single sentence, single layer perceptron is one layer of hidden, and multi-layer perceptron multiple hidden layers. So single layer perceptron cannot classify a non-linear data points. Multi-layer perceptron can classify non-linear data. You have multiple hidden layers. Single layer perceptron takes in a limited amount of parameters. Multiple layer perceptron withstands a lot of parameters. Single layer perceptron less efficient with large data. Multi-layers of perceptron highly efficient with large data. Let me tell you again. You have output layer, one hidden layer, input layer, and the one output layer. and hidden layer. This is your single layer perceptron. We have input, output and multiple hidden layers. That is the multi-layer perceptron. What is data normalization in deep learning? The data normalization is a data pre-processing step. You see, these are two data. One is not normalized, one is normalized. I'll give you an example. You have a sound, say audio file, and this is how it looks. This is not normalized. If you want to normalize, you just put it between some boundary. So you have made it normalized because we want every data to be between certain range. Okay. So data normalization is a pre-processing step that is used to refeed the data into a specific range. So this ensures that the network can learn effectively as it has better convergence when performing the back propagation. Because you cannot have somewhere very high, somewhere very less. You have to put it inside certain range. So if you see here 58 for 51, 41. So range is from 41 to 58. Now you have 43 to 54. So this is how the data should be in a normalized form. What is forward propagation? Forward propagation. Forward means going ahead. Propagation means streaming or sending. So forward propagation is the scenario when inputs are passed to the hidden layers with weights. So you have weights here. These are different, means output layer, input layer, and inside we have hidden layer. So in every single hidden layer, the output of the activation function is calculated until the next layer can be processed. Okay, it is called the forward propagation, as the process is beginning from the input layer and it moves on and on till it reaches the final output layer. This is forward propagation. The reverse of this is back propagation. Backward propagation is for just the balancing or reassigning the weights and biases. So as I said, we find out the output and then we find out the mean square error from the actual value, this is true value and predicted value. Then you find out make a loss function, then you try to change the weight 1 so that you get a good result, and you do it for every weight. So then we find out the gradient descent, that is for optimization. So now you change the weight, that is weight is reassigned as W1 minus eta, delta L by delta W1, this eta is the learning rate. So weight you have changed. Now when the weight needs to be changed, you have to tell neuron unweight. So you have to go back, and this is done through the chain rule in mathematics or mathematic computation. So starting from the output layer, going back to the input layer, backward propagating, this is called the backward propagation. What are hyperparameters in deep learning? So I told you about gradient descent. So the eta is there. What is eta? Eta is a learning rate. So it is a hyperparameter. So hyperparameters are variable used to determine the structure of a neural network. They're also used to understand the parameters, such as I given you the example of learning rate. For example, number of hidden layers are also there. Number of epochs are also there. Momentum is also there. So for example, eta, these all are very important as far as the structure of a neural network is concerned. I'm not going into the model design and model parameters, but hyperparameters are these. There is a question coming, so I'll discuss more about this in the next question. So hyperparameters, variable used to determine the structure of a neural network. How can hyperparameters be trained in neural networks? So I hope you got the idea of the previous question. Let us start with the batch size, epochs, momentum, learning rate. So hyperparameters can be trained. We have 4 parameters here. So batch size, because you need to change the values. Batch size, this is denoting the size of the input chunk. For example, you have x1 to xn. This can be 100, this can be millions. This can, you don't have a limit for the number. So you want to send it in a batch. So batch sizes can be varied and cut into sub batches based on the requirement. Epochs denotes the number of times, number of iterations the training set is visible to the neural network so that it can train. This is iterative. Number of epochs will vary based on the data. So let us talk about learning rate. Learning rate is used as a parameter to denote the time required for the network to update the parameters and learn. It is between 0 to 1. You can have any value. we have to be very specific with the chosen value. Momentum is used to understand the next consecutive steps that occur with the current state being executed at hand, because sometimes there is a oscillation problem. So in order to avoid this oscillation while training, we need a proper momentum value to be set, etc. What is the meaning of dropout in deep learning? So whenever we talk about deep learning, we know that we are talking about the neural network, artificial neural network. So this is a technique that is used to avoid overfitting a model in deep learning. This is to avoid overfitting. If the dropout value is too low, then this will have the minimal effect on learning. But if it becomes too high, then the model can underlearn. That will cause lower efficiency. So this is the standard neural net. But if you see, these are the cross. That is, we have dropped some neurons. So this is after applying the dropout. Okay, that is called the dropout. What are tensors? You might have heard about the tensile strength and Tensorflow, etc. This tensor actually has come from the physics. Tensor, this means multi-dimensional arrays in deep learning that are used to represent the data. For example, I am making an array. The programming people might be knowing what I am doing this. So this can be 1 dimension, 2 dimension, 3 dimension, multi-dimension. So they represent the data with higher dimension. So this is 1 dimension, 2 dimension, 3 dimension. And due to the high level nature of the programming languages, the syntax of tensors are easily understood and broadly used, because this is actually the input to our deep learning programs, right? So the APIs, the different deep learning algorithms, they take this as input. So just see here, this is a 1D tensor, one dimensional tensor. This is the 2D tensor or matrix. This is 3D. You have 2D along with the third dimension. Just assume x, y, z axis like this. Then we have the 4D tensor, vector of cubes, and then the 5D tensor, that is the matrix of cubes. So vector, matrix, cube, vector of cubes, and matrix of cubes, these are tensors. What is the meaning of model capacity in deep learning? There are two terms actually, model capacity and model complexity, generally asked. So in deep learning, the model capacity is referring to the capacity of the model to take in a variety of mapping functions. How many functions, different kind of functions it can take. So higher model capacity means a large amount of information can be stored and dealt by the network, right? So this is the model capacity. And if you see this graph of model complexity versus the prediction error, so this is showing the test data also and training data also. And with test data, by this we may know that how much underfit, overfit, what is the optimality, whether we have achieved it or not. What is Boltzmann machine? So Boltzmann machine, the picture says it all. The blue are the visible nodes. The red ones are the hidden nodes, hidden layer nodes. But there is no output layer. So this Boltzmann machine is a RNN type of machine, recurrent neural network, that uses the binary decisions alongside, of course, the biases to function. So this binary decisions, so these are RNNs that uses binary decisions. So these neural networks can be hooked up together to create deep belief networks, quite sophisticated and able to solve the complex problems. So how does this happen? Normally what we do, in a simple feed forward or back propagation, we have an input layer, then we send the input to the hidden layers. But if you see very closely this Boltzmann machine, every node is connected to other node. See here, every node is connected to another node. So the input layer and the hidden layer, that is the computational level and the values which are coming, the weights and the biases, everything which is computed, and this is how the machine learns by itself, making it better. What are some of the advantages of using Tensorflow? So Tensorflow is an API. I'll just tell you, this is an end-to-end open source platform. Open source, that is, you know the source, you can play with it, and this is a machine learning environment, you can say. It has an ecosystem environment of tools, libraries, and the community resources that helps developers easily build and also deploy the ML powered, machine learning powered applications. So what are the application areas of Tensorflow? You can build and train the machine learning models easily using very basic or intuitive high level APIs, like you can use Keras, which is the wrapper around this Tensorflow. You can train and deploy models in the cloud, on-prem, in the browser, or in device, irrespective of language you use, and quite powerful experimentation for especially research with a simple and very flexible architecture of TensorFlow. So let us just summarize what we have seen. It is flexible, high amount of flexibility and platform independence, and trains using both the CPU and GPU. Machine learning and especially the deep learning involves sometimes GPU. Supports auto differentiation and its features, handles thread and asynchronous computation easily. And thread means these are lightweight processes. Open source and has a large community. What is a computational graph in deep learning? So not even in the deep learning, computational graph by itself is a different entity in mathematics, in discrete mathematics, etc. So computational graph is a series of operations that are performed to take in inputs the mathematical computation and arrange them as nodes in a graph structure. So it can be considered a way of implementing mathematical calculation into a graph. So for example, you have A plus B. So this helps in parallel processing and provides high performance in terms of computational capability. So A plus B can be written like this, but just to make say a somewhat complex, this is an expression, ax squared plus bxy plus cy squared. So this is x now squared, y now squared. Then you have x squared has to be multiplied by a, y squared has to be multiplied by c, and then b has to be multiplied by x and y, and then they have to be added. So this is the whole computational graph that is employed in deep learning, and as I said, that it helps in parallel processing and provides the high performance in terms of the computational capability. As you see, this particular expression is being computed. What is a CNN? CNN stands for the convolution neural network. So these networks that are used to perform the analysis on images and visuals. So just assume that this is a small image, say 28 by 28 or 30 by 30. Now these are the input neurons. How many numbers of neurons? Just take a proper number so that we can multiply. 30 into 30, that is 900. 900 inputs. So that will be very difficult to handle by the artificial neural network. That is why we have the convolution neural network. So these class of neural networks can input a multi-channel image and work on it easily. So this is how there is a shift, or you can say, from this RNN and CNN, just because NN cannot handle certain things, especially the images can be handled by CNN. Convolution is that you have a kernel or a filter, and that is applied on the whole image, convol one by one. So this is, as I said, these classes of neural network can input a multi-channel image. Just understand that this by a picture. This is input. Say take any feature. Then the convolution is done. Convolution is like this. If you have image and there is a kernel, say 3 by 3 or 5 by 5 kernel. For example, it is a Sharp filter or say Sobel filter, and this is applied. and is shifted, and that shifting to each and every pixel is called the convolution. And then this convolution along with the function, say ReLU function, this is applied, and then the pooling is done. See, pooling, max pooling, etc. is done because that much of data has to be contracted. Then again it can be done, for example convolution, ReLU, then pooling, so multiple times it can be done. This is the part where feature learning is there, because image has different features. Then what happens? Then you have to flatten it, and then apply the function, say softmax. So this is flattening. So convolution, pooling and flattening. This flattening is a part of classification. So these three are, we will talk about this, a question is coming. So these are different parts of a CNN. So what are the various layers present in a CNN? So we just talked about this right now. So we have convolution, then pooling, and finally you have flattening. So, and we have the function application also, convolution, the pooling and flattening. These are the major one. So convolution, these are layers consisting of entities called filters, edge detection filters, etc. that are used as parameters to train the network. This is convolution. Then we have the ReLU. So this is an activation function. You know how it performs. All on the left of the axis, and the right you have a linear response, ReLU. Then the pooling is the concept of shrinking of complex data entities that form after convolution, and is primarily used to maintain the size of an image after the shrinkage. This is pooling. This is the very important step in order to handle a huge amount of data. This pooling is done. Okay. So pooling is that step, and then we have the one more step is there, connectedness. So this is used to ensure that all the layers in the neural networks, they are fully connected, and activation can be computed using the bias easily. These are the various layers present in a CNN. Convolution, pooling, flattening. You can also add the activation function ReLU and the connectedness. One part is for feature extraction, one part is for actual classification. So this previous question and this question, they are almost related. What is an RNN in deep learning? So RNN, as I said, it is standing for recurrent neural network, which form to be a very popular type of ANN, and they are used to process sequence of data, text, genomes, handwriting and more. Even if you want to, say some traffic is there, and you want to put some gadget here and try to find out what was the traffic previous. So this also, recurrent is all about temporal data. It's time based, right? Because we need to keep the track of the time also, and the previous one also, previous data also. For example, in Gmail you write as soon, it will all by itself will give you the idea as soon as possible. So RNNs make use of back propagation for the training requirement. So this is very this is basically back propagation through time. So what you have to keep in mind is RNN is all about temporal and time related neural network. What is a vanishing gradient when using RNNs? So there is one more question coming, which is the exploding gradient. So vanishing gradient and exploding gradient. So vanishing gradient is a scenario that occurs when we use RNNs. Since these RNNs make use of back propagation, that is, we need to change the weights. So gradients at every step of the way will tend to get smaller as the network traverses through the backward iteration, that is the epochs. So this equates to the model learning very slowly. Thereby, it is causing efficiency problem in the network. So vanishing is again when we are doing back propagation, the gradient at every step tend to get smaller as the network is traversing through the backward iterations. One more related question is exploding gradient. Exploding gradient in deep learning. So this exploding gradient is an issue causing a scenario that clumps up the gradients, clumps up. So this creates a large number of updates of the weight in the model when training. So when the slope tends to grow exponentially instead of decaying, this problem is called exploding gradient. This is a loss of information through time. So these are the weights. So what does it do? As I am saying that this creates a large number of updates of this weight. Weight are updating, and there is a large number of update while training. So the working of gradient descent is based on the condition that the updates should be small and it needs to be controlled. So controlling the updates will directly affect the efficiency of the model. If you remember, eta was there, the learning rate in the gradient descent algorithm, that is the optimization algorithm. So we don't want the vanishing as well and exploding as well. It has to be balanced. What is the use of lstm? So lstm stands for long short term memory. So it's a type of RNN that is used to sequence a string of data. String of data, RNN, of course, we're talking about the recurrent neural network. So lstm, so it consists of a feedback chains that gives it the ability to perform like the general purpose computational entity. So here if you see, there are certain pictures which I showed, and these say the sequence of string, because every LSTM part has a proper activation, and there will be a gate also, and there will be a memory also. Okay, so that all those things, that is having the previous knowledge, putting it forward. Where are autoencoders used? Autoencoders, it has a lot of variety of uses. So now this is the autoencoder picture. So you have the input, then it goes on decreasing till certain limit, and then it goes again back increasing. Finally, the initial data is retrieved back, whatever is given. The number of inputs is equal to number of output. This is how a normal autoencoder is seen, because the first part is called encoder, the second part is called decoder. So there are various use. For example, feature learning is there, dimensionality reduction, and you can also call it as it can decompress. Decompression is there. Information retrieval is one of the use, and there are other uses also. For example, adding color to the black and white images. This it can do. Removing the noises from the images, that can be done. Dimensionality reduction can be done, as I said. Feature removal and variation, this is also autoencoder can do. So what are the types of autoencoders? So there are four main types of autoencoders: deep autoencoders, convolutional, sparse, and contractive autoencoders. So if you see, there is a slight variation. We have autoencoder, variation autoencoder, denoising autoencoder, and sparse autoencoder. These are types of autoencoders. What is a restricted Boltzmann machine? Restricted. In Boltzmann machine, all the nodes are connected to all the nodes, all the other nodes. There will not be any output node, output layer actually. But the restricted Boltzmann machine is all about restricting certain connections. So the graph is self-sufficient. So here, say for example, V1 is not connected to V2. So the restricted Boltzmann machine is an undirected graphical model that plays a major role in deep learning. It was initially introduced as Harmonium by Paul Smolensky in 1986, and it gained big popularity. So dimensional reduction, classification, regression, collaborative filtering, feature learning, and topic modeling, this is used. Okay, this restricted Boltzmann machine. So as I said again, Boltzmann machine, every node is connected to other node, and this is how the data from input is also coming back. That is, the weights and other things, activation and all these, they are getting updated. Of questions. What are some of the limitations of deep learning? So whenever we talk about deep learning, we are talking about the neural networks, artificial neural networks. So before going to the limitations of deep learning, you must know the limitation of machine learning. So there are advantages and disadvantages of machine learning, because the limitation are being asked, so it can be asked for machine learning also. The first is, in machine learning, there are high chances of error, time and resources is too much, data acquiring is a problem, and also the result, whatever it comes, the interpretation can be difficult. These are the disadvantages of machine learning. But there are advantages also of machine learning. There is no human intervention, wide applications, handling of multi-variety data, continuous improvement by ML, and easily identify any trend and patterns. Now coming to the deep learning, what are the disadvantages of deep learning? So here, networks in this DL, deep learning, requires a huge, humongous amount of data to train well. Along with this, these DL concepts can be quite complex, and in order to implement them, because the complex ideas are there, concepts are there, it becomes somewhat difficult sometimes. Achieving high amount of model efficiency is always difficult in most of the cases. What are the variants of a gradient descent? So gradient descent we have already talked about the GSD, etc. So this is for optimization. For example, the weights, and when these weights are to be changed or are to be updated, there has to be some way so that we get an optimized way of doing it. So this is where the gradient descent comes into picture. So there are three variants of gradient descent: stochastic, then we have the batch gradient descent. Batch, you know the word batch means, that is, you have entire data set and then you take them in batches. So a mini batch gradient descent. So let us take one by one the stochastic GD algorithm. So here a single training example is used for the calculation of gradient and for updation of the parameters like the weights and biases, etc. Coming to the batch gradient descent, gradient is calculated for the entire data set. And means entire batch, and parameters are updated at every iteration. This is batch gradient descent. Mini batch gradient descent, here the samples are broken into smaller sized batches, that is some smaller size data set, and then worked on as in the case of the first one, that is the stochastic gradient descent. So you see here, this is a comparison table also, because the next question is on the basis of this only. So let me explain here only, that is the stochastic, this GD algorithm, the accuracy is low and it is less time consuming. The batch GD algorithm, the accuracy is quite high, but it is very time consuming. But if you come to mini batch algorithm, both are moderate. So why is mini batch gradient descent so popular? What is the reason? So if you have just seen the comparison table, here I wanted to highlight the mini batch and cost also. So what is the difference? Mini batch algorithm, as we said, both the accuracy and time consuming or time consumption is moderate. So mini batch gradient is popular. First, it is more efficient when compared to the stochastic gradient descent, and the generalization is done by finding the flat minima. So what happens whenever we use this optimization, we don't want to be stuck on a local minima or a local minima basically. So we need a optimal solution. So we want the main minima. It helps avoid the local minima by allowing the approximation of the gradient for the entire data set. What are deep autoencoders? So we have already talked about autoencoders. So we have the multidimensionality reduction, decompression, denoising, outlier detection. All these autoencoders would do. But here we are talking about deep autoencoders. So these are an extension of the regular autoencoders. The first layer is responsible for the first order function execution of the input. Please remember, first layer, first order function execution. Second layer, second order function execution. And this goes on and on. We can see or say that this deep encoder is a combination of two or more symmetrical deep belief networks, where the first, the shallow layers consist of the encoding part, the other layers take care of the decoding part, the deep encoder, right? Why is the leaky ReLU function used in deep learning? So you might have heard about the sigmoid function. It gives you result between 0 and 1. Then came the ReLU. This is also very, very important, widely used. Then the Google came with swish. So the leaky ReLU is an improved version of ReLU function. What is the difference? So ReLU activation function, the gradient is 0 for all the values of inputs that are less than 0. This is the ReLU function, means all 0 on the left side, that is the, say, negative x-axis. You get value on only positive x-axis. So this would deactivate the neutrons in that region and may cause dying or decaying ReLU problem. But here, in improved ReLU, it is not 0 there. If you remember, what does the ReLU will give you? 0 max. Anything on the positive, negative x-axis will be 0. Then you, on the right hand side, that is the positive x-axis, you get max. But this problem was improved in leaky ReLU, and you get some value because you don't want dying ReLU. We want to activate the neurons because this is an activation function. So we cannot just say 0, oh, we don't want these neurons. We want them if they give the good result. For that we need to have some function. So this deactivation wouldn't happen. In swish also you see there is the same thing which they have done. Means they had some function value. This is the swish I am showing you. What are some of the examples of supervised learning algorithm in deep learning? So in deep learning, the main supervised learning algorithms. So you can talk about artificial neural network. In that also you will come as convolution neural network. Then we have the recurrent neural network. So artificial neural network are feed-forward neural networks. So this is used to perform basic pattern and image recognition. Then we have the recurrent one. So this is used in NLP or natural language processing and speech recognition. So how it can know the voice and text. Convolution, this is used in object recognition and video analysis. So image, vision and video, IVV, this is why this is used. What are some of the examples of unsupervised learning algorithms in deep learning? So in unsupervised learning algorithm, autoencoders are there, Boltzmann machines are there. Then we have self-organizing maps. We have talked about them all. So let me just show you the picture. These are the three: autoencoders, Boltzmann machine, self-organizing map or SOM. Can we initiate the weights of a network to start from 0? So let me just give you first what will be the scenario if we give 0. initiate weights with 0. So W1 is 0, W2 is 0, and till Wn we have given 0. So what do you get in this input? X1 into W1 means anything x can be, but you get 0. Again x2 into W2 0. So you are getting all zeros. Now you add these zeros with the bias. Bias is a constant. Then you pass it through activation function. So every time you will get the same value, whatever you do. Weights are not being changed, not changing because they are not having any effect at all. You have given W as 0. So there will be no improvement. So it is possible to begin with 0, but why it is recommended? Because setting up the weights to 0 initially will cause all the neurons to produce the same output and the same gradients when performing the back propagation. This would mean that the network will not have the ability to learn at all. You have to give some asymmetry 0.2, 0.8, 0.5 like this, because there has to be some asymmetry between each of the neurons. The absence of asymmetry will cause this kind of problem. What is the meaning of valid padding and same padding in CNN? Let us understand what is the padding. Then you will understand what is valid padding and same padding. So let me show you here. See. So this is the data, which is the inside one. So when we apply the kernel or the filter may be some edge detection filters, maybe SCAR or some Sobel. Now when you are applying it, it is convolution, that is one by one you are moving this window over the image. There is the filter on that image. Say it is 3 by 3. So the computation will be multiplication of each terms of the kernel and the corresponding image, and then you add them and put it in the center one. So when you do this, when you put the first one, what will happen to the 156, 155? Okay, you will have to start such so that this, when you do this with the first one, 156 also get value. Otherwise, only the internal will get some value and outside will be remaining like this. So you have to add some pad, means some extra layer on the sides. So valid padding, it is used when there is no requirement for padding. The output matrix will have the same dimension after convolution. So it will work on each and every pixel value. So let me reiterate. It is used when there is no requirement for padding, valid padding. So convolution is all about multiplying the filter and just moving it so that every pixel is covered. So in same padding elements are added all around the output matrix. It will have the same dimensions as the input matrix. This is same padding. So padding is required because we don't need or we don't want to leave any of the pixel value. And this padding can be valid or same padding. What are some of the applications of transfer learning in deep learning? So it's just like transferring of knowledge actually. So transfer learning is a scenario when a large model is trained on a data set with a large amount of data. And this model is used on a simpler data set. How will this help? It will help in you will get an extremely efficient and accurate neural network. So this is a scenario where a large model is trained on a dataset with large amount of data. So in traditional ML, this was isolated and single task learning. So knowledge is not retained or accumulated. Learning is performed, that is considering past learned knowledge in other tasks. That is, it is, you can say standalone kind of. For data set 1 we have running system task 1, same for the data set 2. Transfer learning of a new task relies on the previous learned task. So this knowledge what you get from the first data set, you are sharing it for the second data set 2. So learning process now can be faster, more accurate and need less training. That is how transfer learning is important, and the popular examples is BERT, RESTnet, GPT-2 and VGG16. How is the transformer architecture better than RNNs in deep learning? So there are new words coming up, right? So transformer architecture, how has it come? This is the model architecture of the transformer. So what was the problem the programmers were facing? When they were using the sequential processing, they need to use high processing power, high GPUs, etc. And because this is sequential, so there will be always a difficulty whenever the parallel execution has to be done. So this caused the rise of this transformer architecture. So there is a mechanism here which is called as attention mechanism. And this attention mechanism is used to map all the dependencies between these sentences. We are talking about RNNs, remember, thereby making huge progress in the case of NLP models. Attention mechanism. So we cannot go to the detail because this is the question answer session. But right now you just have to say, because this is an interview question, so what you have to speak, these basic things you should know, that what you have to speak and how does this work. Transformer architecture, why it came and how it is making the RNNs in deep learning better, or it is better than RNNs in deep learning. What are the steps involved in the working of an lstm network? So we have talked about the long shot, this term, this kind of M network, memory network. So how does this work? First, let us understand that this is a previous cell state. This is a new cell state. This is the previous hidden state. This is the new hidden state. So you have the input data. So we have the pointwise multiplication, pointwise addition. Also we have some tanh functions and sigmoid functions. These are the activation, deactivation functions. And these are simply the activation functions giving you certain value, whether the neuron will be activated or not. Now, just understand that in LSTM, we have the gates. We have a memory also to keep the previous state, and the gate has to be open or to not to be open, what to be fed, what not to be fed, all is there in LSTM network. So the three steps you need to understand here is, the network picks up the information that it has to remember and identifies what to forget. That is, to remember it will keep, to forget it will just leave. Now this cell state value which I just showed you, these are updated on the basis of the first step which I just told you. What to remember, what to forget. And then the network will calculate and analyze which part of the current state should make it to the output. Okay? So these are the steps involved in the working of LSTM. What are the elements in Tensorflow that are programmable? So this is, learning Tensorflow needs a lot of effort. But for now, time being, you need to know that constants, variables and placeholders, these are the elements in Tensorflow that are programmable. So in any programming language, you have to have variables, you have to have constants, you have to have the placeholders like the different data structure, arrays, etc. What is the meaning of bagging and boosting in deep learning? Bagging, boosting. So just understand that we have a data set. We are splitting the data set and now we are placing it into certain bags, imaginary bags, randomly for training the model. So this is the bagging. Just relate it with the bags. So take the data, split it and place them in certain bags, randomly placing it into the bags. So this is bagging. So this is for training the model. When we are talking about boosting, this is the scenario where the incorrect data points are used to force the model to produce the wrong output. That is, the wrong data should produce wrong output. So when the wrong data is producing the wrong output, the good data will produce the good output. Okay. So this is used to retrain the model and increase accuracy. Incorrect data forced to produce wrong output. This is boosting, bagging and boosting. GANs are now asked, in almost every this AI interview, what are generative adversarial networks? So these generative adversarial networks, let me just show you here that there are two wrestlers, two people fighting. Wrestler. So what happens that in the local championship, say Asian, so you lost to the other one. Then World Championship also you lost to the other one. But now you are going to Olympics. Now you know that you have to generate enough power so that the discriminator, which is the other adversary, you need to make certain efforts so that you can beat him. So you are the generator, the other adversary is the discriminator. I hope you got the idea. So this is how this GAN works. The generative adversarial networks are used to achieve generative modeling in deep learning. So this is an unsupervised task that involves the discovery of patterns in the input data to generate the output. So the generator is used to generate new examples. It is generating. While the discriminator is used to classify the example generated by the generator. So this is an example of real and fake one. So the generator is generating the fake samples. And there is real samples also coming. So the discriminator will discriminate or tell which is the real one and fake one. So if this discriminator is correct that this is real or fake, if it is incorrect, fine tuning will be done both for generator and discriminator. What do you think? If you're a wrestler, other person will also want to beat you. And while this beating is going on, you get a good result. That is how you get very good image when it is a noisy image. The question comes out of this is why are generative adversarial effect this is so popular. So these GANs are so popular. So these GANs are used in variety of purposes. In case of working with images, these GANs, they have a high amount of traction and efficient working. And this has given a very thrust to different kind of easily done work. For example, creation of art. GANs are used to create artistic image, sketches and painting. Image enhancement, resolution of input images can be increased. And you can change the aspect like day to night and summer to winter. This can be done very easily with the GANs. For example, as I gave you example, denoising. So where you have an image with a lot of noise. So you have a discriminator, you have the generator. So they two are working together just like the previous example of wrestlers. So when the result will come, you will see that because of their kind of contemporary or adversary, you get a good result. So this is all about the advanced question. Thank you so much. Take care of yourself.